Okay, trigonometry. You can follow along with me if you like from page 224 of your textbook that's in front of you, New Zealand Maths. And the first thing we're going to learn about trigonometry is how to label the different sides of the triangle. So to start off with, we have a right angle triangle. Now, at year 11, every single trigonometric triangle you deal with is right angle. So alarm bells should go off if you're looking at a problem without a right angle in it. I'm going to identify one of the other angles that's not a right angle, and I'm going to call it theta. That's just a symbol that looks like this, and yeah, it's just like a letter, but it just identifies one of the angles. Can anyone recall for me from maybe year 10 the name of the longest side of a triangle? Well done, Liam. You must have had a great teacher last year. Yeah, he's right, the hypotenuse. And sometimes abbreviated, well, often I'll just use a capital H, but the side opposite the 90 degree, right, is always the longest, and we call that the hypotenuse. Can you lock that into your memories? There are two other sides to this triangle that can potentially swap around depending on what angle I identify. In this case, I've identified this one. So this side here is called the, I can hear someone saying it, was it? Adjacent. Good morning. Thank you. Okay, and again I'll abbreviate that with a capital A. What does that word adjacent mean? Join to? Not join to. Close. It means next to. So I'm sitting adjacent to the filing cabinet. Okay. Matt is sitting adjacent to Liam. Adjacent just means next to. So that's a good way of remembering. The adjacent side is next to. Sure, did you want to carry on? No? The adjacent side is next to the identified angle. Can you picture that? So the side that's next to the identified angle is called the adjacent, which means next to. The opposite side of the identified angle is called the opposite. Funny that, eh? The opposite side is called the opposite. The opposite to the identified angle is called the opposite. And again, I'll abbreviate that with an O. So just quickly, if I change the orientation of the triangle, put the 90 degrees there, identify this angle, opposite the 90 degrees is called the hypotenuse, opposite the identified angle is called the next to the identified angle is called the adjacent. Okay, in this part of the exercise, question 1, all we're going to do is identify whether it's a sine problem, a cosine problem, or a tan problem. There's an acronym that we use in trigonometry. Thank you again. SOHCAHTOA, right? That's how we can remember the different functions. The SOH stands for sine of the angle is equal to the opposite side divided by the hypotenuse. I'm going to use these sort of cheap triangles that you use in science. Right, those ones. And I'm just going to substitute this formula into one of those triangles. I'd put the sine down here, and I put the O here, and I put the H here. How many have not seen these triangles work before? So, how many have seen these triangles work before? Okay. This group here, have you seen these triangles work before? Some have. No, do you remember? Okay. I'll explain it in a minute, but the cosine of the angle, this is this acronym here, must equal the adjacent side divided by the hypotenuse. And then the tan of the angle, this one here, must equal the opposite over the adjacent. And I'll just substitute those quickly into triangles. A and H, O and A. Now, for those that think trigonometry is magic, it's not magic, because if I give you two sides of a triangle, two lengths and an angle, right? If I told you one side was 3, another side was 4, and you had a 60-degree angle between those two sides, there's only one triangle in the world that you could draw. Can you picture that? If I told you two sides, a 3 and a 4 say, and the angle between those two sides is say 60 degrees, there's only one triangle in the world that you could draw. So then we shouldn't be surprised when I divide those two sides, and take one of the trigonometry signs of the angle, I get a certain ratio. I don't really want to go on, you don't need to know all that, but trigonometry is not magic. It's just based on the ratios of triangles, and it always works. Okay. As I said, all we're going to do is identify in this next exercise which function that we need to use. So this is the first question on page 228. It's got a 90 degrees there. And if you look closely, the H has been identified as A. And the X has been identified, and remember, this is the angle, so opposite the angle is O. Which triangle do I use if we've got an O and an H? The first one, okay? Set up a trigonometric equation connecting the angle and the sides given. So we're looking for O, because that's the x, right? Are you with me? I'm on page 228. We're looking for the opposite. So just explaining how these triangles work, what you do if you're looking for the O, and we are, you cover up the one that you're looking for with your hand, right? And then if sine of the angle is next to the h, that you multiply across this way. So the answer, the O becomes the hypotenuse length, which it happens to be A. We don't know the number. A multiplied by sine of 65. If I reversed the problem on you and told you we were looking for the h, and we knew the O, we would cover up the one that we're looking for, which is h, and you would go O, the opposite side, and divide it by the sine of the angle. And these are how those triangles work. I'll do it a few more times so people catch on, but the answer to this problem is x, or O, one or the other, is equal to, covering up the O, h times sine angle. And I'm going to call h A sine 65. Next question. Here's letter B. Got an angle 32. Got a length or a hypotenuse straight away. I'm going to put the h in there, and I've got a length x. Thank you, A. Someone already called out A. That's the A, isn't it? Because it's next to the angle. Sean, what trig function would I use if I'm dealing with an A and an H? Yeah, the cosine. Okay. And in this case, I'm looking for the A, because it's the x, right? I'm looking for the x, which is the A. I cover up the A, because I'm looking for the A. And I've got cosine of the angle multiplied by the hypotenuse. So it's B cosine 32. You getting this? X equals B cosine 32. There's my answer. Next one. Cody, this one's for you. Okay, I'm going to label the sides. This is the H over here, so H is not involved in this one. X is opposite the angle, so I'll call that O. And C is next to the angle, so I'll call that A. Cody, which triangle up there deals with O and A? Tan, right? So, tan of the angle, whoops, tan of 56. I'm looking for the X. I'm looking for the X, which happens to be the O. Cover up the O. A times tan of the angle. X is equal to A, which is C times tan of 56.